Okay, so with these conclusions from our mini section firmly in hand, let's look at gliding vertebrates. And I think this is important because there are lots of animals that fly in creature design, but in reality, there are lots and lots and lots of gliders. Not only are there far more different types of gliders around today, and by different types, obviously there are a lot of birds in bat species. What I mean is birds are simply one group that learn to fly, and bats are simply another. So there's only two groups of flying vertebrates alive today, and there's only three in history, in the entire history of Earth. You know, you throw in pterosaurs, and that's it. But there are at least 3 dozen different groups of vertebrates that learn to glide independently. Here's a handful of them. We'll look at some more later. And notably, without exception, all of them have learned to glide in the trees. Flying fish actually fly in the sense that they actually generate a little bit of lift by flapping their wings. They don't generate enough lift, Michael, to fly, obviously, indefinitely, but part of that's also their metabolism. They don't have a high aerobic metabolism that would allow them to do so. So they combine the speed of their jump with their flapping. But they really do flap, and they really do generate thrust from that flapping. Well, welcome, Luke. So, anyways, but on land, tetrapods, everything there develops gliding in the trees. Also, some of them are really cute, I should add. But you'll notice this big area underneath it and how it connects to the body. That's really important. But here's some other animals. Here's a gliding lizard, and I want to point out that while this guy has a big area under his body, this is all skin membrane that's attached to the legs. This little lizard doesn't actually attach to the legs at all. It's attached to the ribs. And I don't see this get used enough. This is a pretty cool way to make a wing. Here's another gliding lizard that also uses extended ribs. They actually hinge the ribs, by the way, so these can fold up when they're not being used. And this is so common that here's an extinct animal called Icarosaurus. This critter lived in the Triassic before the dinosaurs had officially taken over the Mesozoic, and it did the same thing. It has these elongated ribs that supported wings. So this is actually a really common solution, and that's why it's disappointing that we don't see more gliding animals or creatures in people's designs. When we do see them, they're almost always using limbs rather than some other solution. Here's something I'll throw out. This is a little animal called Blongisquama. We don't know that it was a glider. In fact, I suspect that it wasn't. But it really did, on its back, have this long set of dorsal appendages. They're not feathers, but they seem to use some of the same developmental genes. And I like these. If you want to do something crazy that doesn't involve feathers, like 2 sets of these might actually allow for at least parachuting or something if they could be moved. So even if this guy couldn't do it, that would be a fun thing to do with a little gliding creature. And it's sort of akin to what they did in some of the big flying animals in Avatar to give them little doohickeys sticking off and stuff. Okay. One thing I really want to key you in on, though, okay, what are the wings made of? This is skin membrane stretched between ribs, skin in between, ribs, skin in between. This is skin in between the limbs. No muscles, or not many muscles in any of these, mostly just skin and perhaps a little tiny bit of muscle to help them fold up and get out of the way. Otherwise, just skin in between them. These probably are made out of some sort of keratin. So something, whether it's a specific type of beta keratin, more like feathers, or more like the alpha keratins we find in current scales, I'm not sure, and nobody knows because I don't think anyone has looked at them under a scanning electron microscope just yet. Okay, so back to these guys. All animals that glide like this actually develop airfoils that connect to their stomachs. Even the famous, this picture's backwards, even the famous tree frogs that can jump out and glide and have this webbing in their toes, even these guys actually expand their stomachs and get much, if not most, of the gliding surface on their stomachs, and they use that webbing actually to control themselves, to steer. So this idea of airfoils, gliding surfaces connected to your body, is incredibly important. And actually, animals that do evolve flight from groups like this also have airfoils that attach to their bodies. Pterosaurs do, and of course bats do. And this is important, I think, because there is another group. These guys are flying lemurs. They don't actually fly. They do glide, but they're incredibly good at it. They're not actually lemurs either, but they're not too far off of primates. And this is, again, skin stretched between not just the fore and the hind limbs, but between the tail. And this is a very good model for what bats came out of, even though it wasn't literally this group of guys. It would have been something sort of like this. But there's another group of animals that fly, birds, and if you go into their fossil record, their wings don't look anything like that. If you look at winged dinosaurs that didn't fly, or even early ones that may have flown, the wings actually start out far away, both at the end of the tail and at the ends of the hands, and over time grow inwards more and more until you get a complete wing, and it goes further up the tail, which suggests something very funny about dinosaurs, that there weren't really hardly any gliding dinosaurs at all up until you get really close to birds. Here, for example, is Velociraptor, and Velociraptor we actually found quill nodes on the ulna, the forearm bone, and quill nodes, of course, this is a living bird here, are used for anchoring really well-developed sets of wings, which is how we know that these guys had them, but again, based on other relatives, those wings did not go all the way up the arm. So they're being used for stuff on the ground, not for gliding. They weren't even thinking about jumping out of trees or anything like that. We'll talk more about, bats and pterosaurs and dinosaurs in just a little bit. But first, what do gliders tell us? Well, first of all, there are way more gliders than flyers out there in terms of how many groups have independently come up with it. There's only 3 groups of animals that have developed powered flight amongst the vertebrates, whereas there are like dozens and dozens that have developed gliding. So if you're trying to come up with a cool creature that people don't see but should be utterly realistic, think of making some sort of a glider. If you do that, though, probably you should stick them in trees. The first winged non-flying dinosaurs were not gliders. They're doing something totally different. We'll talk about later. And if you are putting them in trees, if they are actual gliders, you probably want to have whatever their wings or airfoils are made out of attached to the stomach and the body. That's like a universal rule, pretty much. And as I pointed out earlier, don't just use the limbs. Ribs, even like giant hinged ribs, are great ways to make gliders. And honestly, although I haven't tried to come up with a way you could muscle the ribs, it would be kind of fun to try to design a flyer that actually could flap those ribs sufficiently to generate lift. That would be a hard challenge, but it would be fun. Yeah, no, sorry, Michael, the velociraptors in Jurassic Park are not accurate. We know now that all dromaeosaurs were not just covered in fuzz, but actually had proto-wings and feathered tails. As a general rule, you can say that the X in Jurassic Park was not accurate. They may have been some of the best dinosaurs committed to film at the time, but that's not the same thing as being accurate, it turns out. I think that would make a really interesting dragon if you could come up with a way of doing that. Yeah, that's a really good idea, Abraham.